Okay, so for those of you that don't know a ProView, I will tell you that it is a super efficient in a memory footprint database that is highly customizable to get the job done. Did I do that well?
There you go.
Okay. So
ProView is the company.
ProView is the company. Panorama is the database. Sorry. And I'll let him tell you just a little bit more about it. So Jim and I were talking about, well, what was he going to talk on this year? Because he's talked at every...
No, I missed two.
You missed two? Almost every...
When we had the foster baby.
Yeah, exactly. MacTech conference. And we started getting on this conversation about regular expressions, and we realized how many people really don't know fully about what they can do with regular expressions. Now, we use the stuff all the time at MacTech, and so I thought this would be a really, really fun talk. I thought that was a terrific idea to do. And I will try to watch it a little bit as well. So
it's not for you.
It's not for me? Nothing's for me, right?
No,
So without further rambling, I'm going to try to hand this over to Jim, who is going to do a talk on the practical introduction to regular expressions. How about a warm welcome for Jim Ray?
Great crowd. Okay, so as he said, I've been around on the Mac for a long time, and actually this November is the 30th anniversary of Panorama. Now, if a few of you, how many of you have, know regular expressions? A few hands. So I designed this for the rest of you. Those that raise your hands, you can hang around, but it's designed for, I figure there's a lot of people that, you hear about regular expressions and you're like, I should learn about that. People rave about it, but it seems big and mysterious and weird, and I don't know where to get started. So I'm going to try to get you started in a way that, try to demystify it and get your toe in, and hopefully at the end of this you'll all, at least feel that you could do some simple stuff with it. You all can. It's one of those things that I think people try to make mysterious, and it's, it can be, but it doesn't have to be right from the get-go. So what are regular expressions? Fundamentally, they're simply a method for pattern matching. They provide a flexible and concise means to match strings of text. It's kind of like a search and replace function of a word processor, but on steroids. Compared to other techniques, regular expressions can be much easier to understand, short, code. Now I'm going to not go into the details of this right now. We'll build this up later, but I just wanted to show you that that's a pretty short thing to describe what the pattern is for a zip code. And so here's a little example. Hopefully I can get this to play. I've got a little GIF. All right, well, I'll show you this later, but I've got a database. It's got 20,000 records in it, all the US airports, and I've got a regular expression that I use to find all of the improper zip codes in this database. And it does it like that with a pretty simple regular expression. So I just wanted to give an idea of what we're going for, because I'm going to show a lot of basics. But towards the end, I'm going to show you some real-world examples of why is it showing that slide again? Now, there are potential disadvantages, and regular expressions aren't always the best solution for every problem. Sometimes the advantages can turn into disadvantages. They can, be cryptic and indecipherable. Here's an example of regular expressions gone crazy. What do you suppose this regular expression does? In fact, what this is for validate. It's a regular expression that will check if an email address is valid and or not, and it's very, very detailed and complicated. But don't worry about this. We're not going to have you do stuff like that. Now, learning regular and working with regular expressions is a lot easier with a specialized regex development tool. I picked up this program called regex RX a few years ago, and I've been really happy with it. and I'm going to use it for most of the examples in this session. It's $5 on the Mac App Store, and I definitely recommend it. There's other programs out there that I think are probably just as good, maybe even better, I don't know, but this is the one I know. But I really recommend that you pick up some tool like this. So these tools allow you to interactively play with a regular expression, and like as you type, they're showing you what the results are. There's also some websites, free websites, that can do this too. So find some tool like that, and that'll make all the difference. So here's a closer look at regex RX, hard to pronounce. So at the let's see, at the top section here, you put your regular expression pattern, and then here in the middle you put the text, the sample text that you want to search through, and then at the bottom it shows you the results. So as I said, the primary use of a regular expression is to determine if text contains a pattern, and if so, where that pattern appears in the text. And the most basic pattern is simply a series of characters. So this is a really basic pattern. It's HELLO. So it's saying, look through this text, and is there anything that has letter H followed by letter E, LLO? And yes, there's one place. Whoops. There's one place. There's one match, and it's at position 49, length 5. Now you say, well, we knew it was 5, hello is 5, but you'll see later that the length of the match isn't always the same as the length of the pattern. So this is really just like search and replace, or search in a word processor, right? So that's the simple sort of degenerate case. You're probably never going to use a regular expression that's just a series of characters, but that's the starting point. And I'm going to just start with this, and then very gradually add more things to show you the power of it. So if the text contains multiple occurrences of that text, it'll find all of them. So I got the same pattern, but I changed the text, and now there's two instances of hello. Now, regular expressions can also be used to find and do a replace. So in this case, it's just like find and replace in Word or any other word processor, and I've just said find hello, and any place it occurs, change it to goodbye. And so the interface to regex is pick, search, or replace, and whatever tool you have, that's sort of outside of regular expressions, so different tools will do that differently. And then now here's the sample, and then there's the results showing it's replaced goodbye. And later I'm going to be showing you much more powerful examples where it's not just a literal, replace this with that. So let's look at start looking at some more sophisticated patterns. One thing you might want to do is look for a pattern that only matches a specific spot in the text, perhaps the beginning or the end. So for example, now again, I've just got hello, and this text I put in has 3 hellos, the beginning, in the middle, and the end. And the pattern is matching all 3 of them, as you'd expect. But if I add a caret at the front of the pattern, can you see the caret? Those of you in the back, there's a caret. That's a special character in regular expression. There's a bunch of special characters I'm going to be showing you about. And that, if you put a caret at the front, that says this match has to be at the front of the text, nowhere else. So we're still looking for hello, and there's 3 of them, but it's only matching the first one, not the one on the end, not the one in the middle, because we're saying we don't want those. We only want the one at the beginning. Now here's another slight variation. I put a $sign on the end. That means I only want the match at the end. So it ignores the ones in the middle. So does this text end with hello? If I put a caret at the beginning and the $sign at the end, then that means the match has to be at both the beginning and the end. And so there's no matches because there is no hello that's at the beginning and the end. There's different hellos at the beginning and the end, but this pattern says, basically what it says is, it will only match if the text is just hello and nothing else. And later you'll see this can be really useful for things like validating data import, data input into forms, for example. Like, say you build a regular expression that's going to see, does this match an email? Well, you don't want it to match an email and something else. You want, if the user only typed an email and nothing else. So you want the email address at the beginning and the end. So you would do it this way. And I'll have this exact example later. Now, as you've seen, the caret and the $ are special characters in a regular expression pattern. But what if you wanted to search for a $? So wait a minute, we can't search for it because that has a special meaning. So what happens is when there are special characters that you want to actually include to search for in your pattern, you do what's called escaping them. And that means you put a backslash in front. So you just put a backslash, a backslash, and then whatever the character is. So let's say here, I want to search for 345, which I have here. And so, but if I put $345, you think, well, oh, I just search for it, right? But that doesn't work because the regular expression is saying $, that means match at the beginning. So, and you don't have any such thing. So what I do is I escape the $. So now it's saying match the character $, and then 34567, and now I've got a match, and it works. So, when in doubt, put a $sign in front of it, because it won't hurt. Even if if I put a $sign in front of an A, that'll still work. It'll just say, yeah, that's an A. Okay. So now, actually, in this particular case, I had 345.67. And it worked because of a weird thing, well, not a weird thing, but dot is actually a special character, which I'm going to talk about later. So actually, if you wanted to use dot to search for it, like in this case, I want to actually search for a period, I have to escape it and put the backslash to have it work properly. So now, earlier we talked about positional matches of being at the beginning or end of the entire text. Sometimes you may not care that absolute position, but you might want to make sure that something is at the, either at the beginning or end of a word or not at the beginning and end of the word. So let's look at how we can do that. So here I've got, again, a very simple pattern, just good. And there's 4 matches of good. So good, soft goods, hard goods, and goodbye. So only one of those is the word good, and the others have that embedded in something larger. So if I change my pattern and put \b, good, and then another \b on the end, now it is only matching good where it's a word. So the B stands for boundary. So it says only match if this is a word boundary. So what this pattern means is look for a word boundary, then the word good, then and a word boundary. So it's only finding the word. If you make it a capital B, now this is one case where it's important, the upper and lower case, that reverses it. It says find things that are not a word boundary. So now I've made it capital B, so the word good is not found because that's got word boundaries, and we don't want that. Soft goods and hard goods are found because those are embedded, no word boundary. Goodbye is not matching because although it's embedded, at the beginning of it is a word boundary. So it says that doesn't match because our pattern says, we don't want a word boundary at the beginning of it. Okay, now let's start to get to some of the really good stuff, character sets and classes. So far, the patterns have only contained said match a single character at each spot. But you can also set up a character set, which is a list of characters that match, or a character range, for example, all letters or all numeric digits. Okay, we're doing pretty good on time. A character set is a square bracket followed by a list of characters and then a closing square bracket. So in this case, I've listed A, E, I, O, U, so that's all vowels. So this pattern will find all the vowels in your text, and you can see that there are 39 vowels in the text. And you probably can't see in the back, but they're all highlighted in there. Now, you can combine that with other regular expression elements. So I put a $sign on the end. So now this says, well, is there a vowel as the last character of the text? So, and yes, there is. It's the letter O. But all the other, now we've knocked out all the other vowels and only finding the vowel at the end if there is one. If there was not a vowel at the end, then there'd be no match. You could put other stuff. So here I'm saying, is there any occurrence of an N followed by a vowel followed by an M? And there are two of them. Name, N-A-M, and numbers, N-U-M. So it's N followed by any vowel followed by an M. So what you do is you just build up to make what you need. So here's an example where I've put two character sets next to each other, and it's saying, look for two vowels in a row. So we've got a few of those, seems and good and look. And in all these cases, they happen to be repeated, but they don't have to be. It could be a different, like AU would match. Or it says a vowel followed by M followed by another vowel. So A-M-E and I-M-E. Now here I've just said, okay, I want to find every numeric digit, so I just listed them all, 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. And so it's matching each, and notice this is going to be important, it's matching each digit, so not the number as a whole. And later in a minute I'm going to show you how to match into runs of multiple items. Now, this is something you might want to do a lot, find numbers, right? So kind of inconvenient to type all those 10 digits. If you wanted all the alphabet, you wouldn't want to have to type 26 digits, A, B, C, D, E, F. You could, but so for that we have what's called ranges. So you can say 0-9, and that's what's called a range. And so that means that match 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. So a range will match all the characters in between the start and end in consecutive order. And by consecutive order, that means Unicode order. So the characters in Unicode between 0 and 9 are 1, 2, 3, 4, 5, 6, 7, 8. If I say A-Z, then I'm going to get all the alphabetic characters. And usually those are the only two ranges that are pretty common. I mean, you could go into a Unicode table and figure out sometimes other things, but those are the two that you'll tend to use a lot, A to Z and 0 to 9. And, okay, so I'm just saying that state. Okay, now regular expressions can work in either case-sensitive or case-insensitive mode. And I've been using case-insensitive mode. So that if I said A to Z, that didn't matter if it was upper or lower case. But it is possible to work in case-sensitive mode where you can differentiate. Now, in regex RX, there's a pop-up menu that allows you to select what mode you're using, and different tools will do that differently. So you want to look at the documentation for whatever it is that you're working with to learn how to change that. And there's also a way to embed into the regular expression. I'm not going to cover that if you want to force either case-sensitive or case-insensitive. So if I switch to case-sensitive mode, I'm searching for uppercase A to uppercase Z, and see it's finding only uppercase letters and not matching lowercase letters. So then if I put lowercase a to lowercase z, now it's finding only the lowercase letters and not the uppercase ones. So for the rest of the session, I'm just going to use case-insensitive mode unless I happen to tell you otherwise, which I don't think I do. So anytime you see letters, upper and lowercase will match each other. Now, within a set, you can have multiple characters as well as multiple sets and multiple ranges. So here I've got a pattern, and it matches numeric digits, 0 to 9, and also a $sign and also a period. And notice, well, okay, so you can see it's matching $, 3, 4, 5, 6, 7. All those are matching because that's what's in the range. Now you'll notice that I didn't escape the $sign and the period. And it turns out that normally you'd have to escape those characters because they're special characters, But inside a character set, you don't have to escape them. So most things you don't have to escape inside a character set, so inside the square brackets. But there are some characters that still need to be escaped if even inside a character set. For example, square bracket. What if I wanted to have a square bracket included in the character set? Or what if I wanted, so then I need to put a backslash in front of it. Or what if I wanted to have the backslash character in a character set? Then I have to escape it with a backslash. So here's an example where it's matching square brackets. Now, an interesting thing that you can do with character sets is if the first character is a caret, that is a special character, and that says reverse this, instead of matching the characters I'm listing, match everything but the characters I'm listing. So by putting, normally A-E-I-O-U would say match all the vowels. By putting a caret in front of it, that's saying match anything but vowels. So if you look at the match, it's matching all the consonants and the spaces and the punctuation, but not the vowels. So sometimes it's easier to say what I don't want to match instead of what I do want to match. Now, let's take this and extend it a little more. So I've made a little bit longer pattern. So it's going to start by saying don't match vowels, but then it's going to say also don't match numeric digits. So no vowels, no numeric digits, and no spaces, and no dollar signs, periods, or commas. So what do we got left? Consonants. So we just made a pattern that matches the consonants in here. Now, this pattern is kind of fragile because, for example, punctuation, I only listed a few punctuation characters that happen to be in this text, but general text could have question marks, it could have hashtags, it could have asterisks. There's lots of special symbols, and it'd be kind of a pain to list all of them or even figure out what they all are, right? So the regular expression people have you covered there, and they have these things called character classes. So there's one called punctuation, and the way you do that is you put a square bracket, a colon, and then punct and square bracket, colon. Okay, so that means all of the possible punctuation characters that Unix has. So this is a better way to search for consonants. Now, how did I know that there was such a class? Well, you have to look it up in a table. So here's a list of, I guess if you do enough of them, you're going to memorize a few of them. But there are about a dozen character classes, so like uppercase letters. So some of these that you could do other ways very easily, like upper is the same as A-Z. And there's the punct down there. Now, if you're using a tool like I recommended, like regex RX, it has a little help menu, and you can just pop that up. It's got the list, and it'll type it in for you. So that's another reason why it's handy to use a tool that will help you with that. Or you could buy this shirt that I got off of Amazon, which is, you can't really see it from where you are, but it's a regex cheat shirt. And it's got a whole regex cheats upside down. So right here, there is the punct character class. I bought that just for this session. So here's a revised version of my consonant pattern where I went ahead and changed like 0 to 9 to digit, and instead of putting in a space, I used the space class, which will also pick up tabs and character turns and any kind of white space. So this is an alternate way of picking up all the consonants. So you can decide for yourself whether you like this better or the one that I originally did better. They work exactly the same. Now, of course, a lot of times there's more than one way to skin a cat with regular expressions. So here's another way to match consonants, just list them all. So in this case, I'm not sure which is better. But sometimes, you might, develop something and go, well, maybe that's not the right way. Look around. There might be a better, simpler way to do it, or, at least an alternate. So there's usually not just one way. So now, a very useful feature of regular expressions is the ability to look for repeated matches. So start with the plus, which is real powerful. That means one or more matches of the item right in front of the plus. So this says O plus, so that says look for any place where there's one or more plus. So, so we've got, hello, the O on the end, and then good, or I've got one with 3 O's. So, and it's matching. Now, unlike if I just said O, it would also find all the O's, but it'd find each one singly. So now, you'll notice here, it's finding this as one match of 3 O's. And that's going to be useful later, because like say I'm doing a replace, to say, I want things to be found as a collection and not as repeated individual things. So now here's another repetitive thing. You can put curly braces and specify a minimum and a maximum, and optionally, in this case, I left off the maximum. So this says whatever's in front matched 2 or more times. So in this case, it's O. So it's no longer matching O's that are by themselves. It's only finding where O is repeated 2 or more times. And, or here now, instead of saying O, I'm saying look for vowels. So any vowel that's repeated. And so you can see seams, goods, etc. So whatever's in front of the repeated thing, it can be a complicated thing, and you can use parentheses to make a big group and say, this whole thing, is it repeated? Okay, so here is a pattern that matches 1 or more digits in a row. So in other words, this will match integer numbers. So you can see it matched 3, 4, 5 as a unit, not as the digits 3, 4, and 5, and 6, 7 as a unit. So that's helpful. Now, let's say I want to find, I want to find money items, and we'll assume we're in the United States, although there's a way you could make this more universal. So I'm going to look for a $sign, so I put escape $sign because the $sign's special, and then 0 to 9 1 or more times. So now it's matching that $345 as a unit. And if I replaced it, it would replace that entire unit, including the $sign. Now, let's say maybe there's a $sign and maybe there isn't. And I want to match it either way. So now I've got another special thing called question mark, and that says that the previous item is optional. It can be there or basically the previous item can be repeated 0 or 1 times. Okay? So now you'll see that it's matching the 345 with a $sign, but also the 67 with no $sign, and the 35 with no $sign. Now, that last thing is actually equivalent to this. Remember we had this min max? Okay? Well, so question mark is exactly the same as the previous item is repeated 0 times or 1 time. So that might help you understand what the question mark is really doing. It's a repeat. And you can use this notation if you wanted to. And using that notation, you could also say, well, it's repeated 0 time, 1 time, 2 times. Maybe there's more than one $sign and you want to allow that. That makes it an easy way to do that. So now I can, I've got a number in there, 345.67, and maybe I'd like to match the whole thing as a unit. It makes sense. So I've got a decimal point and fractional digits. So what I do is I've got my original thing, and then I say, yeah, look for a period, so escape that, and then more digits, right? So now it's matching the whole thing, $sign 34567, the whole thing's finding as one match. And if I did a replace or did some other operation on it, it would do the whole thing. Only problem is now we're not finding the 35 anymore because that doesn't have the period. So how can I match both of those? Well, with my question mark. So I use put the question mark on the end, but what I want to make optional is not just one thing, but the whole period and 67, right? So it's a compound thing that I want to make optional. So what I do is I put parentheses around it. Parentheses are allowed. So I say this whole thing can be repeated 0 or 1 times. So now it's matching that, but it's also matching the 35 because and notice it did not match the period after the 35 because what it's saying is optional is a period and digits. So if the digits aren't there, the period is not part of the match. So now I'm using a replace, right? So I've got that same pattern, and I'm replacing it with redacted value. And so now you can see why it's important to match these things as an entire item. So it's taking the each entire number, and 3, 4, 5, 6, 7 is replaced with redacted value. And it's not saying redacted value over and over again for each digit, just once for the whole number. And the same thing for here. So this is going through and redacting all the numbers. 10 minutes? Okay. 61. We're not going to make it to the end. So the dot character is a special character that will match any character. So here I'm saying a space and dot dot space. So that means match anything where there's a space and then any characters. So doesn't matter what the characters are. And here, anything with 3 characters in between spaces. Doesn't matter what the characters are. Now I can use my repeat thing. So here I've put just the max. So or no, this is just, if you do it without the minimum, then it says it must be that amount. So this is the same as the dot dot dot, saying a space, 3 anything, and then another space. So anytime there's 3 characters in between a space. Now this can get weird when you start making the numbers bigger. So let's say I say 15. You think, well, that'll find any word 15 long, right? No, because space is also a valid character that will match dot. So you know, I'm getting things that have multiple words in it. So dot turns out to be pretty hard to use. It's often not very useful. Like you might think that you could match a word by saying space and then any number of characters and then a space, right? Based on the rules, that's what a word is, a space, then some characters, a word. No, that doesn't work, because what it does is it goes from the first space and it grabs everything, and so you can't do it that way. Now, there's a thing called greedy. You can turn that off. Then you get a different kind of thing. We're way behind, so I'm going to skip that. So here's a good way to get a word. Just say any number, say 1 or more letters, and that's a good way to get a word. Did I go back or something? Okay. So let's take a look at a closer look at patterns, because there's some really cool stuff you can do that. So I'm going to start by creating a pattern that'll match the last word in each sentence. This looks for 1 or more letters followed by a period, question mark, or exclamation point. So here I've got 1 or more letters, A to Z, plus 1 or more times, and then a character set that says period, question mark, and exclamation mark. So see, it's finding the last letter, the last word in each sentence. So now I'm going to put up a pattern and say, replace that with gone. So I've changed the last word in each sentence to gone. Okay. But what I can also do is I'll put $0 in my pattern, and what that says is take the value that we found and put it there. So now instead of gone, it's saying put the word in there, but surrounded by asterisks. So you see, we've got customized. You know, we've just sort of put some stuff around it. But it also included the period or punctuation. Maybe I don't want that. Maybe I just want the word itself. So what I can do is set up what's called a capture group. So this first part of this, A to Z plus, that's what's capturing the word, right? So I want to take that and use that in my replacement. So what I do is I put parentheses around it, and then as it's doing the search, the regular expression will take that and stuff it away, okay? And so now I'll change this to $1, which says take the first capture group, and you'll see in a minute we can have more than one. So now see, it's replacing, you know, just Jim, not Jim period, and just hard goods, not hard goods period. Got it? So we can take parts of our match and use them in the replace in a smart way. And I can set up 2 capture groups. So now I've set up a second one to capture the punctuation at the end of the sentence. And then I'm using that as $2. So now I'm putting the gem in the middle in between the asterisks, but then the punctuation is still going at the end. So pretty simple.
Neil said I can give you about 10 extra minutes.
Oh, awesome.
If you think that
I can, yeah, I'm 70. Have a few more minutes, so great. I think that's great, right? Okay, so yeah, so as a regular expression can contain up to 9 capture groups. So $1, $2, $3, $4, up to $9. I don't think I've ever used more than 3 if your head starts swimming. And $0 was always the whole thing. Okay. In my replace, but if I did, like for the first one, it would have been gem period, and the second one would have been hard goods period, and the third one would have been art. In other words, the entire match. So capture groups are partial parts of the match of the thing you found. So $1 is some partial, and $2 is some partial, depending on how you set up the parentheses. $0 is going to be the whole thing. You usually don't use $0 if you're also using capture groups, but you can. There's nothing stopping you if you've got an application. So showing you a lot of theory. So let me try and show you some real world examples. So I'm gonna perform these demonstrations using my database program, Panorama 10, which supports regular expressions. If you're not familiar with Panorama, you can find more about it by visiting www.proview.com, and there's a free trial, and you can download it. So, I'm gonna do 3 examples. I'm gonna search for invalid zip codes in a database. I'm gonna take phone numbers that are formatted different ways and make them all formatted the same way. And I'm gonna check data entry to see if it has a valid email address. So I've got slides for these, and at the end, hopefully I'll have a few minutes, and I've got a copy of Panorama in here, and I'll actually show you live these things happen. But first I'm gonna do the slides so that I can walk through all the steps. So here's a database that contains all the airports in the United States, got this database off the federal FAA. And so there's almost 20,000 records in there. I don't know if you can see that little number. It's like 19,400 and something. So there's a field in here that, if you can see it's circled over there, contains the city, state, and zip code of the owner of the database. So as I mentioned, this data came straight from the FAA. So maybe it's a government database. Maybe it's not all valid. Maybe there's some problems there. I'll give you a hint. Yes, there are. So I'm going to use a regular expression to check to see if every record actually includes a valid zip code. So I'm going to start by pressing Command F, and that brings up the find select command in this program, the search command, which Panorama searches for data. And that brings up this dialog that has a bunch of options for searching. And there's a pop-up menu, and it's got a bunch of things like search for contains, or but notice down here we've got one that says search for matches regular expression. Okay, so that's what we want for this class. So we bring that up and it says, okay, we've got the field already, owner, city, state, zip, matches regular expression. So I'll just start with a real simple one. It says 0 to 9 5 times, and at the end, $. So look for, does it contain 5 digits at the end of the field? And if you look up here, it says, yeah, 17,825 of them do out of 19,000. So, but that's not all of them. So some of them do, well, most of them do, but not all of them. Now, some of these, though, have 9-digit zips. Well, okay. So I'm gonna change this pattern, and I'm gonna say add look for a dash, and then look for 4 more digits. So now it's looking for 9-digit zip codes, and you can see it found 1,400 of them about in here. There are 1,400. So, but now it's not finding the ones that have only 5 digits. So we'll handle that in a minute. But it's finding all the ones that have 9 digits. So we're going to use that optional thing. So I put parentheses around the last 4 digits and the dash. So I said, so now it will find all the ones that have 5 digits and also all the ones that have 9 digits. Make sense from what I did before? And so again, now it's saying, oh, we got almost all of them. 19,263 out of 19,519. So there's just a couple hundred that don't match. So I wanted the ones that didn't match, so what I'm going to do is go back here and reverse my, my search, and instead of saying all of the following are true, I'm going to say none of the following are true. And so now it's saying, okay, there's 256 that, that don't have valid zip codes. And a lot of those are just completely blank. They have no information. And I'm not really interested in that, so I'm going to add another search criteria and say, okay, is empty, and since I want none, that's going to kick out all the ones that are empty, and it's going to show me all the ones that are not empty but don't have valid zip codes. And a lot of those are just missing, but you can see some of them, like Crescent City, well, there's only 4 numbers there. So that's not valid, so it failed the regular expression. And if I go ahead and actually do the selection, we can see scattered through here, like Hanford, that has a 93230 instead of 0 on the end. And these other ones have missing digits. So very quickly, my regular expression found all the ones that were missing. So now let's look at formatting phone numbers. So I've got another field over here on the right. It's got phone numbers, and you can see some of them are formatted with parentheses and some just dashes. So what I want to do is make them all format with parentheses. So to do this, I went back to regexrx and said, okay, let's figure this out there, and then I'll take that back to Panorama, and I came up with this regular expression. So notice that this actually does more than I need for my Panorama application, because this is actually reformatting phone numbers inside of text. It's finding them and reformatting them without even separating them out. So it's using capture groups, like I said it before. So I've got, it looks for first an optional parentheses. Let's see, did I? Yes, I made slides for this. Okay, so first we look for an optional leading parentheses. So it might have one, maybe it does, maybe it doesn't. And then we look for 3 digits, and we're going to capture that. So I put parentheses around that, so that's our first capture digit. So 09 repeated 3 times, so that's the area code. And I put the capture group in my replacement pattern. So then I'm looking for, possibly looking for a parentheses after the area code. So I look for that, and the question mark means it could be there. Actually, a parentheses and a space, so it might be there, it might not. We'll match either way. And then there might be a dash, so I'll say, okay, look for, is there a dash? And so potential mistake here, this would also match if it was like 213 parentheses space dash. You're probably not going to have that, but I'm just going to choose to say I don't care. So then we have the local number, which is going to be 3 digits, followed by a dash, followed by 4 digits. And again, I made a capture group out of that, so I put that in my replacement. So the whole thing is capture the area code, then capture the local number, and replace everything I found with the formatted version of it. Make sense? So let's go back to Panorama. And what I'll do is I start by opening the Find and Replace dialog. So this is a dialog that's normally just, replace hello with goodbye. But it has an option. Instead of words, say replace using a regular expression. Okay, so I'll go ahead and pick that. So now I go ahead and take that regular expression that I made in our regexrx and put it in. So I put the pattern over here and the replacement pattern over here. And then I just press the replace button, and bingo. All my phone numbers are formatted, and they're all in the same format. And I think we'll have enough time to show you. I've got this database on here. Ooh, my ear is falling off. Am I working? Yeah, okay, good. Okay, so my final example is validating email addresses as they're entered and warning if there's a problem. So this is a different database. It's like a contacts database, and I've got an email field. And over here, I've got the properties for that field, and one of them is the code. So this is code that will run when you press the return key. And so you notice it says, if not, email regex max. So it's saying, I'm going to check the email using a regex. And let's see, I think I'm going to explain that in detail in a second. So I'll just show it. So if I enter like john.mail.net, that's invalid because it doesn't have an @ sign. And so that code is going to come up with a little alert and warn me that it's no good. But if I put in a valid email address, then it will not give me a warning. So by now you can probably figure out, here's the regular expression that I used for that. So we want to start with the beginning of the text because we don't want anything in front of our email address. And then we want letters and numbers and underscores. And then we want an @ sign, and then we want letters and numbers and underscores, and then a period, and letters and numbers and underscores, and a $sign. And now, this is a pretty simple checker, like I showed you one earlier, that's a lot more complicated. In fact, there's like reams of the internet that are devoted to how to validate email addresses on the internet, and I mean with regular expressions. There's some people that say, just don't do that. But for something like this, it's going to be, a simple one can knock out, 95% of the problems, and then you can worry about the rest other ways. If I've whetted your appetite, there are a lot of books and websites where you can learn more. These are two of my favorites. Now, the one on the left is it might be way more than you want to know, but that's out there. And then Regular Expressions Cookbook is just basically it's filled with handy things that instead of figuring out yourself, you just go and say, how do I do this? And there's tons. If you go on the internet, there's tons of websites that are full of cookbooks and stuff like that. So let me just really quickly here. See if I can mirror displays. And so here is that U.S. airports database that I had. And so I can come up and do find select like I showed you. And I've actually got that search canned, so you won't have to watch me type it. So invalid zip code. So you can see there's the regular expression. It's kind of tiny, but can you see it? And then I just pressed the select button, and boom, just that fast. It went through 20,000 records and found all the ones that had invalid zip codes. And then we've got my phone number field. And let me, again, so I don't, I made a little program that has this code. So I could just run it, but let me do it the way I showed you. And come up here and say find and replace. And now I'll switch to regular expressions. And why isn't this? Oh, there we go. It's being fiddly about. So now I've got to get rid of the extra stuff. And then put in the replacement, and get rid of the extra code stuff, And hopefully I did all that right, and we just say replace, and boom. It just reformatted the whole thing. And then that other thing I did with the email, that's in this database. So, okay, here's my email field. I use reverse scrolling on my machine. So let's bring up the properties. And here's the code. So if I double click to edit this, and when I press return, it's going to warn me because this has a plus in it, and my pattern didn't allow a plus. So it says that's not valid. So I can go in here, and actually let's make this wider so you can see this expression a little bit better. And so I'll add a plus to the character set. And now it accepts that one. So that's basically my talk. One thing I didn't talk about where you can use regular expressions. It's a feature that's not part of a particular program, but so if different programs can use it. So like BBEdit has it, Nicest Writer has it, Panorama has it, number of programming languages have it. Does Word have regular expressions? I'm not sure. And the nice thing is, although there can be some little variations, like pretty much everything I showed you here, you can learn it once and it'll work in all of those programs. So it's kind of a universal tool. So hopefully I've encouraged some of you to go out there and kick the tires. Next year, tell me all about what you did.
Ladies and gentlemen, Jim Ray.